So what we know that about the function, all of you, we know that the function is a subprogram or a small program which is a part of a main program, and this can be a particular function that will be used to do some particular task. To specific task will be performed by that function. So function is a subprogram, or function will be a procedure. Function will be a function. The particularly function will be done some task which will be given for that function. So that function will be done a specific task. So that can be achieved in any program in C that will be written many number of functions. So how many number of functions we can write in C language? We can write any number of functions. And we have already discussed about the function, the definition of the function, library functions, as well as the user defined functions. The library functions which are actually done or actually specified, which is a part of C language, and this part of C language will be actually considered for some specific task, but it has a predefined task. So that is actually designed by the C compiler or those who have designed C language. So that is called as a library functions. But on the other hand, you can say the functions which will be written by the user for performing a specific task, that will be a user defined functions. So any number of functions we can write in C language. So that is the sub function or sub program. And we have seen the categories of the functions. We have defined the function and categories of the functions, where we have seen the 4 different categories. That is the function without arguments and without return value. The second category, the function without arguments with return values. Then the third category, the function with arguments and without return values. And the last category, we have seen the function with the arguments as well as with the return values. So we can transfer the values and we can communicate between the different functions from the main function, as well as any number of functions we can communicate with each other. So if C function program may have any number of functions that will be communicated with each other. Otherwise, some functions will not be communicated with each other. So that was the categories of this function. But what is the recursive function? That the recursive function is a call within the same function. So that is called as a recursive function. So another way you can say the function which calls the same function is called the recursive function. Say in other words, when a function call itself, then that function is called as a recursive function. So the same function will be called in the same program. The recursive functions are very useful to solve many mathematical problems, like to calculate factorial of a number and generating Fibonacci series. Okay, for these 2 examples, we require to write the recursive function. Now, what are the advantages of recursion? The function calling related information will be maintained by the recursion, and the stack evaluation will take place by using the recursion. So in prefix format, in postfix format, these recursive functions will be evaluated some particularly the values. What are the disadvantages of recursion? It is very slow process due to the stack overlapping. Some sort of a slow process will be done by the recursive function. The recursive functions can create a stack overflow. This will be also done. The stack overflow will be done, and these recursive functions can create the loops. So that will be the recursive functions disadvantages. So this is the example of recursive functions which will calculate the factorial of any number. So for example, we give the number 5, we have to calculate the factorial. See, these are at the right hand side in the pink color figure. It shows that this will calculate the factorial of 5, that is returning n into factorial of n minus 1. So always this fact we have to consider here to calculate the factorial of a number. At the right hand, extremely right hand side, the factorial of 5 is exactly calculated with the 5 into 4 into 3 into 2 into 1. Then in the next step, n minus 1 step, that is 4 into 3 into 2 into 1. In the next n minus 1 step, that is 3 into 2 into 1. In the next 2 into 1 as well as 1 into 1. So factorial of 0 and factorial of 1 will be always 1. And see here, that is in the first step, returning 5 into factorial of 4, that will be 120. Then factorial of 4 will be 4 into factorial of 3, that will be 24. See, this is 4 into 3 into 2 into 1, that will be 24. Returning 3, that is n minus 1, 3 into factorial of 2 is equal to 6, and so on. So what will be happen with this? Any number we can give for the factorial, that is 5, the factorial will be directly calculated with the recursive function. Let us see the program which is written here at the left hand side, and that shows the include stdio.h, that is then conio.h, void main is there. The function, integer function, is given here, declared here. Integer I, f and num, that is also given. We have given the clear screen. This is the library functions. The next library function is a printf, enter any number. We have entered 5 for the factorial. Then the value of 5 is taken here, num. So scanf will take the value 5, and this is very important statement, f is equal to fact num. So num value will be given to the factorial function. The num value will be given to the factorial function. So this will transfer, see, let us note here, this will be directly goes to the factorial function. So now function is written in the same program. This is the main function. This is one function, first function, and this is factorial is the second function. So these two functions are written for this program, and we are transferring the control towards the fact function. So fact function has the argument, that is integer n, and integer n is declared here, and then the same thing which is written in the main program, the same statements are written here in factorial function. What is that? See here, if a is less than 0, if a is less than 0, the value will be minus 1. If a is equal to 0, return 1. So the factorial of 0 will be always 1. Otherwise, see, this is very important. What is that otherwise? Returning n into factorial of n minus 1. N into factorial of n minus 1. So what is that? the n into factorial of n minus 1 is actually calculating the same here, actually returning the value of 5 into factorial of n minus 1, that is 4. So this 120 will be calculated. So 120 will be get calculated. Now what is that? After calculating of factorial, so this fact function is exactly the same function written here. So that will be the same function will be get recursively called here. Okay, so after that the value will be returned to the factorial function. So that will be done here, and the factorial is get calculated, and the returning value will be displayed with this f. So f will be the value of that particular factorial. The value of factorial 5 is 120. So that is the factorial of any number you can get calculate. Okay, so what is the next? See here, the same thing will be done here. The same thing will be done here. For example, the value of or n is equal to 4, the factorial of 4 we can get calculated here. So factorial of n will be n is equal to 4, then print 3 factorial, then print 2 factorial, print 1 factorial, print 0, and we are returning the 0. Return 0 in the same way we can return into the main function. So print that will be 4 will be stacked tracking for the recursive function call. Okay. Now let us see the next very important aspect of C language or C functions, that is the storage classes. What is this storage classes? In C language, each variable has a storage class which decides the following things. What is this storage classes? Particularly, each variable has some storage class. Now we have actually declared many of the variables in our programs, but every variable will have some storage class where we can store that particular variable that is decided by the language. Now any variable has its scope. Any variable has its initial value, and every variable has its lifetime, or you can say longevity. So scope, what is the scope? Where the value of the variable would be available inside a program. So that will be its scope. So what is the scope of any variable? That is the scope particularly for that particular program. We can use that variable, or for any other program that can be used. That is its scope. What is the next? We have to initiate some value. So if we do not explicitly initialize that variable, what will be its default initial value? So some sort of a variable value we have to initialize, or otherwise in some calculation part that value will be initialized, or that value will be get calculated. But every variable in a program that will be having some value. Now the variable has its lifetime. The variable has its lifetime, So what is that lifetime? That lifetime of that variable, that is for how long that variable will get exist. How long this variable will get exist? For example, if we say that we have a lifetime, how many years we have a lifetime? What will be the age? Maybe around 100 years a person can live on this earth. So what will be the lifetime? So that will be 100 years. What will be the scope? Anyhow, you can say any person can travel each and every country. That will be its scope. So this is a particularly a scope and lifetime of a variable. But you can say those variables have the scope and lifetime, as well as there are some different categories of these variables which we can use in number of functions. So with the help of this scope and lifetime, we can divide some variables in different classes. So what are those classes? The first class is a automatic variables class. So the storage classes has four different classes. That is, first is the automatic variables, second external variables, third static variables, and fourth register variables. So these number of variables we can declare and we can use with its scope and lifetime, as well as the initial value we can declare at the time of declaring the variable. So first we have to see the automatic variables. Let us see, this is the automatic variables, that is called as a auto. So what is the scope? This variable has a scope. Variable defined with auto storage class are local function block inside which they are defined. So that is called as a automatic variables. So default initial value, any random value, or that is the garbage value that is also can defined. So what will be the lifetime of automatic variable, that is auto variable, till the end of that function or method block where the variable is defined. So what is the syntax of automatic variable? See here, auto integer number. Auto integer number is a syntax of this automatic variable. So auto, what is this auto? This is a keyword. We have studied about these keywords. So auto is a keyword, integer is also keyword. So number, we can just return the name of this variable, that is number. So a variable declared inside any function without any storage classes. This is very important. Without any storage class specification. So that will be by default an automatic variable. If you are not specifying anything, that will be called as an automatic variable. For example, integer I, integer j, integer a, integer b, integer sum, any float a, anything. So that all will be called as an automatic variable. They are created when a function call is called and destroyed automatically. These automatic variables will be destroyed automatically when the function's execution is completed. See here, when your function's execution will be get completed, then also this automatic variable will be get destroyed. The automatic variables can also be called local variables. These all variables will be called as a local variables because they are local to a function. Why this is local variables? Because they are local to a functions. By default, they are assigned a garbage value by the compiler. That is also a very good thing for the atomic variable. So this is the example of the atomic variable. See here at the right hand side, the example shows that main function integer details. This is the atomic variable. We can declare for integer I or integer a, that is also integer a. We can declare integer a, that is also a atomic variable. Or otherwise we are writing atto as keyword in this program. If we are writing atto as a keyword, that is also a atomic variable. If you are not specifying here atto, that is also done. Okay, so both are the same. Integer details and atto integer details, both are the same one thing. Sometimes we are not specifying, many times we are not specifying atto, but if you are specifying atto, that will be a atomic variable. Okay, so that is the atomic variable, that is the first storage class. Then the next storage class is the external or global variable. What is the scope of this external or global variable? So the scope, that is the global, that is everywhere in the program. So that will be category which will adopted for a variable, can be used everywhere in the program. These variables are not bound any function. They are available everywhere. See, the atomic variable was a local variable, but external variable is a global variable. See here, external variable will be a global variable. Global in the sense, this will be used anywhere in the program. So this is global. Okay, so default initial value will be always 0 of this external variable. And what is the lifetime of this variable? Till the program does not finish its execution, you can access the global variable. If you are accessing this program and it is not finishing execution, the lifetime of these global variables will be up to that level. But we can use these all global variables in some different functions or in some different programs that will be done with the extern as a keyword. So this is a keyword. Extern is a keyword. What is that? Extern integer number. What we have written previously, atto integer number. Atto is a local variable, that is the integer number is a local variable, but here integer number is an external variable. That is we can use this integer number in many functions in the program, as well as you are using this number in another program also. So what is this? A variable that is declared outside a function. We can see integer number we can declare outside any function, not inside a function. If you are declaring any variable in the function, that will be local to that function. So if you are declaring any variable outside of any function, that will be your global variable. So global variables will remain available throughout the program execution. Throughout the program execution, we can use this global variable. By default, initial value of the global variable will be always 0. And one important thing, to remember that about the global variable is that their values can be changed by any function of the program. So values can be changed with the any function in the program. So external variable or global variable will be declared outside of any function. See here, outside of any function, you can declare this variable. The next, that is an example of external variable. See here, external variable is declared. Let us see the integer number in the main program. The number is declared and initialized to 10. But here, this variable integer number is declared, that is called as a global variable. Now, this number is a different variable which is declared inside the main function. Now, printf function shows that I am a main function and my value is a number. What is that value? Will be 10. So function 1 and function 2 is called here. So this will transfer to the function 1. Here that control will be get transferred. What is that? The function 1 is written and number is initialized to 20. Now this number variable is a local to the function 1. Now printf I am a function 1 and my value is number. See here, the first function value is a 10, second is a 20 here, and the function 2 is again called. The function 2 will be get called to the this function second function. See here, function 2 is written, that is the printf value. I am a function 2 and my value is 20. So that will be a 20 value because the function 1 has 20 and that will be given here. Here, the integer number which is declared outside of the function, that will be a global variable. Okay. So where we can use this external keyword, here external keyword is used with the variable to inform the compiler that this variable is declared somewhere else. So the external does not allocate the storage for variables. See here, file1.c, it is integer a is equal to 7 here. It is a global variable, but this a is equal to 7 is not used here in the file1.c, but it is given into file2.c, and that will be given as an external variable, that is integer a. So that can be used here also. Okay, so that will be done with the external as a keyword. Here in example, the main program shows that external integer x. This is actually developed and declared outside of this function main, that is integer x, it is declared outside. Okay, so that is used inside the function with the help of external keyword, that is external keyword. Next is a static variable. Static variable, that is a local to a block in which the variable is defined. So till the whole program does not finish, the lifetime of this static variable will be always the lifetime of that, the whole program, when we are not finishing that execution. Syntax, that is the static is a keyword. Integer number is equal to value, value we have to initialize. So in the static variable, this will tell the compiler to persist or save the value of the variable until the end of the program. So static variable is a very simple variables. Okay, so it has a different two variables, that is static internal variable and static external variable also. So with the help of a global variable and local variable, we can declare the static local variable and static global variables. Like this, we can use these static variables in program. And Just this is the example of static. You can declare this static in the program itself and in the function. Next is a register variable. This is a register variable. Scope of this register variable, that is the local to the function in which the function is declared. Okay, and the lifetime of this register variable will be